All right, now we're on to part 2 of lesson 43. Remember, first thing you need to do is put your name, number, date, first and last in cursive. Okay, remember, whatever the date you're working on the notes is what you put here. And our subject is math. All right, so we're going to use those cubes, that cube strategy for annotating our word problems to help us with solving these. First two problems we're using a model to help us solve, and then the second two we're going to use an equation to help with each one. So first, circle our numbers. A recipe calls for using 6 5/9 cups of flour before baking, and another 5 4/9 cups after baking. What is the total amount of flour needed in the recipe? So we want to know the total amount. When we do not know the total, we either add or multiply. Are we joining together equal amounts? No, so we're going to add. So here, there's another also to let us know we're adding these. So here's my 1, 2, 3, 4, 5, 6, and 5/9. Here's my 1, 2, 3, 4, 5, and 4/9. What if we take these right here, these 4, and we move them up here? So I'm going to add 1, 2, 3, 4, and then get rid of these. Just going to move them right up here. Did that fill in that hole? That 1, 2, 3, 4, did that fill in the whole thing? Yes, it did. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 filled in. So originally we had 11 and 5/9 plus 4/9, or 9/9. But since that whole thing is filled in, it does not matter that they're cut into ninths right now. We have 12 whole units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is the total amount of flour needed? We do need to know cups. That is a key word also. The total amount of flour needed in the recipe is 12 cups. This is a complete sentence. Make sure you capitalize at the beginning and you have your punctuation at the end. All right, so here, again, we're going to circle our numbers, underline our question, box our keywords, eliminate unnecessary information, and solve our problem. Every day, Mrs. Goodman starts at the beginning of the trail and walks 1 1/4 miles. Then she turns around and walks back to the start. Okay, so miles is the units we're going to be looking at. She starts at the beginning and walks this distance. Then she turns around and walks back to the start. So back to the very beginning. What distance does Mrs. Goodman walk every day? Okay, so every day she walks 1 1/4 miles. So here is my units cut up. So we have 1/4, 1/2. It's hard to see, sorry. 3/4, 1 mile. So this would be 1/4, 1/2, 3/4, 1 mile, and then 1/4. Actually, we'll call this, instead of a half, we'll call it 2/4. Sorry, it's messy. This is why you use pencil and not pen. So the beginning of her trip, she goes 1 1/4 miles. Then she turns around and she goes the exact same distance back. So we need to add these two together. So we have 2 of these, 1 1/4 plus 1 1/4. That's what we're doing, because she walked that distance and then she turned around and walked that distance back. Well, what would we need to finish that 2 miles? So from that's 1 1/4. So here's that 1 1/4. She would need to take 1, 2, 3 pieces off of this one. So 1, 2, 3. This gets added over here. Oops, over here. So that we make the whole thing. So we took the 3 pieces, or the 3/4, added it over here to make 2 miles. Now she's at 2 miles and 2/4 miles. So we just added it over here, physically added it instead of using just numbers. We took the 3 pieces that would make this whole, added it on. So we have 2 2/4 miles. Now 2/4 is the same as 1 times 2 and 2 times 2. Or I could divide both by 2, and I end up with 2 1/2. So now we need to answer the question. We needed to know the distance that she walked every day. Now if it said for a week, that would be different. Then we'd have to multiply it by 7. But it just wants to know what she walks on a daily basis. Mrs. Goodman walked 2.5 miles every day. Okay, our next problem here. Nita needs 1 2/7 liters of water for 1 science experiment. She needs 2 4/7 liters of water for cleaning up afterwards. How much total water does Nita use? So we want to know total water. Our unit is liters. So for the science fair project, she needs 1 2/7. After, to clean up, she needs 2 4/7. We don't know the total, so we're going to either add or multiply. Since we're joining together unequal amounts, we're going to add. And we're looking at total water, so I'm going to use W for water. So total water, we're going to add 1 2/7 plus 2 4/7. First, we need to add together these fractions. 2/7 plus 4/7 is 6/7. That's a standard fraction. I don't need to change it. It's not improper. There's nothing I can divide them both by, so I don't need to simplify. So that's nice. Now all I need to do is add my whole numbers. 1 plus 2 is 3. So how much water did she use? 3 6/7 liters. So Nita used 3 6/7 liters of water. Okay, next. An architect built a road 6 6/7 miles long. The next road he built was 9 1/7 miles long. What is the combined length of the two roads? So 6 6/7 miles, 9 1/7 miles. What is the combined length of the two roads? So combined, that means we're joining them together. We don't know the total, so we're going to either add or multiply. Since we have unequal amounts there, we're going to add. So 6 6/7, 9 1/7. And we're looking at roads, total length of road. So I'm going to use R for road. Okay, let's add those fractions together. 6/7 plus 1/7 is 7/7. Ooh, 7/7, that's the whole thing. Okay, so 6 plus 9 is 15. So we have 15 plus 1 whole more. So that means really I have 16. Because 7 pieces, if it's cut into 7 pieces and all 7 are there, it's a whole road. So 16 miles. The combined length of the two roads is 16 miles. All right, so that's using models or equations to help solve word problems involving fractions and mixed numbers. All right, now you need to practice some more with these types of word problems. Thank you for joining me.